All right, hi folks. Here we are at section 9.5, which is the distance formula. And I think some of you may already know this. Depends on how much your teacher last year taught you. But what we are going to do is we're going to go through, whether you know this formula or not, we're going to go through how it was derived. So like, where did this formula come from? So if we start off with two random points that we place on the Cartesian coordinate plane, say point A has the coordinates of x1 and y1, and then coordinate B, or point B, has the coordinates of x2 and y2. If we want to figure out the length of this segment, or the distance between the 2 points, we can actually use the Pythagorean theorem to help us out. So how would we use the Pythagorean theorem? Well, we have to come up with a right triangle, correct? So what you would do is from point A, you would draw a horizontal line, that's the blue line, and then from point B, you're going to draw a vertical line, so that's the red one. And where they intersect, we get another point. And that point of intersection right here is going to make a right angle, since they're horizontal and vertical lines. Okay? So now what we have to do is we have to come up with the coordinates for this new point. So if you think about it, the x-coordinate, you're going to be going over the same distance until you get to this red line. Well, that red line came from point B, so we're going to go over the same x distance right here of x2. And then we're going to have to come up until we get to this point, and that distance is going to be the same as the y from A, because it's on the blue line. So the coordinates of this point are going to be going over x2 and up y1. Okay, so once we have established these coordinates, what we need to do is come up with the length of this segment and the length of that segment in terms of x1, y1, x2, and y2. So let's think about this. Since this is a horizontal line, the y's are the same, y1 and y1. So we just have to subtract the x coordinates. So we're going to take x1 from this point, subtract the x2 from that point, and that will give us this length. Same thing over here, only this time our x coordinates are the same. See the x2's? So what we have to do is subtract the y coordinates. So we're going to take this y2 up here and subtract this y1, and that gives us this length for that segment. Now I'm naming this d because that's what we're looking for, the distance. So using the Pythagorean theorem, we would know that this side squared plus this side squared is going to equal the hypotenuse squared. So we can write that. Okay, now we don't want to solve for d squared, we're trying to solve for d. So since d is being squared, to undo a square, you take the square root of both sides. So that's how we get d is equal to the square root of x1 minus x2 quantity squared plus y2 minus y1 quantity squared. And that is your distance formula. Now some of you might be observant and recognize that when it's written here, the x2 came first and you subtracted the x1. But up here, the x1 came first and we subtracted the x2. And if you think about it, does it really matter? Because the order that you subtract things in is just going to be a difference of a plus sign or a minus sign. And if you have a minus sign that's being squared, it's just going to turn positive anyway, right? So the answer to that question is no. These are both identical. It does not matter the order that you subtract your x coordinates or that you subtract the y coordinates. Okay, so this is a formula that you guys need to commit to memory. There's a lot of formulas, right? So let's see how this works. Say we had these 2 points, these are the endpoints of the segment AB, and we want to use our distance formula to figure out the length of our segment. So we're going to plug everything in. AB is going to be the square root of x2, which is 6, minus x1, which is 3, and then we square it, plus, and we're going to take y2, which is 4, and subtract a negative 2, which is y1, and square it. Now remember, you can't just take the square root of the squares and get rid of them, because this is an addition problem inside the radical. So we do actually have to evaluate these numbers first. So 6 minus 3 is 3, so we're going to take 3 squared. And 4 minus a negative 2 is like adding, so that becomes a 6 squared. Which then we get the square root of 9 plus 36. Add that together, we get the square root of 45. And this is why we learned how to simplify radicals. 45 is 9 times 5, so that comes out to be 3 root 5. So that's the length, or the distance, between point A and point B. Not too bad, I hope. That was a pretty quick one, right? All right, enjoy.